Start the topic qualitative analysis. In this topic, we are already discussed how we can identify cation and anion by the using of their color, smell, order, etc. So we are already discussing about color. That is the experiment. And next is observation. Third one is inference. So we are taking a salt that is white in color. We are taking a salt that is white in color. It shows the absence of copper plus 2. Since copper plus 2 is a blue color salt, similarly Ni plus 2 it's a green color salt. Fe plus 2 it's a light green. Fe plus 3 it's a brown color. Mn plus 2 it's a pink color. And cobalt plus 2 it's a red brown. So if the color of salt becomes white, then it shows the absence of all these 6 cations. Now we are discussing about smell. The salt having ammoniacal smell means just ammonia like. Then it shows the presence of NH4 plus, that is called ammonium. Now the salt have the smell vinegar like. Vinegar like means smell which comes generally in pickles. So it shows the presence of acetate ion that becomes CH3 COO negative. And if the salt having rotten egg like smell, rotten egg like. So if we are not having any idea about rotten egg like, then rotten egg like smell is just similar to the black salt. So these types of salt indicate the presence of sulfide ion, that is S-2. So these are some preliminary tests. By these tests we are helping maybe presence some of the cation or some of the anion. Now we are discussing chemical tests of the salts. When we are taking the chemical investigation of salts, then first always we are starting from anion. For example, we are having a salt nickel sulfate or nickel chloride or any other salt like copper sulfate. Then this salt, this one is anion, this is the anion, and this anion. So first we have always analyzed the anion. Never first analyze the cation, since there is some anion like fluoride F minus, borate that is BO33 minus, oxalate C2O4 2 minus. These anions are also called interfering radicals. These three are called interfering radicals. Interfering radical means if these three anions present in our salt, then these anions interfere the test in the test of cation. So why these are called interfering radicals? So first we have always investigated the anion, and if we are investigating the anion, then we are investigating that our salt having anion F minus. So we are first removing this F minus from our salt. Then remaining mixture that not contain fluoride ion is further used for the investigation of cation. Similarly, if we are having borate or oxalate, then confirming of these ions, first we are removing of these ions by the using of chemical method, and the removed solution or removed salt used for further identification of cation. So first we are always investigate the anion. Now different types of anion we are classifying into 3 categories on the basis of their reactivity or gas formation tendency or precipitation formation tendency. So simply first we are divided the anion into 3 categories, and first we are always investigate the anion. So in the salt analysis start from anion. So anion are divided into three groups. The first group, that is group A, or that is called dilute H2SO4 or dilute HCl group. In this group we are having the cation. The first one is carbonate, that is CO3 2 minus. Its name is carbonate. And the second is sulfite, that is SO3 2 minus, that is sulfite. And third one is sulfide, that is S minus 2. It is sulfide, S minus 2, sulfide. And the fourth is nitrite, that is NO2 minus. Its name becomes nitrite. The fifth becomes acetate, that is CH3 C double O negative. It becomes acetate. So these five radicals consist of group A or dilute H2SO4 group or dilute HCl group. The second group becomes called group B. It is called concentrate H2SO4 group. Anions of these groups does not dissociate by the help of dilute H2SO4 or dilute HCl. So, for investigating of these group anions, we are using concentrate H2SO4. Now, anions which comes in this group is, the first one is chloride, that means Cl negative. Its name becomes chloride. The second one is bromide, that is Br negative. And third becomes iodide, I minus. Fourth is NO3 negative, that becomes called nitrate. And the fifth becomes fluoride, it is also called interfering radicals fluoride. And next sixth becomes oxalate, that becomes C2O4 2 minus, that's the oxalate. So these six groups makes a group of concentrate H2SO4, means anion of these groups does not react with dilute H2SO4 but readily react with concentrate H2SO4 and gives their presence. Now the third group is called a special group, that is called group C. It's also called a special group. So anion of this group is not decomposed by the help of dilute H2SO4, dilute HCl and concentrate H2SO4. So anion of this group is identified by the using of some specific reagent. So in this group we are having the anions. The first one is sulfate, that is SO4 2 minus. It becomes sulfate. The next is phosphate. It means PO4 3 minus. It's a phosphate. And the borate is also called interfering radical. Now, according to the systematic scheme, we are identifying one by one anion. So always start from dilute H2SO4 group. How we can start the analysis of this anion? So first makes a chart that becomes first is experiment, second is observation, and third is interference. Interference. So we are taking a salt and adding to the dilute H2SO4. Why we are starting dilute H2SO4, not adding to the concentrate H2SO4? Since if we are having the two anions like carbonate and Cl negative. And if we are directly added to the concentrated H2SO4 in this mixture in place of dilute H2SO4. So carbonate, it is react with dilute H2SO4. So no doubt it is also react with the concentrated H2SO4. And Cl negative is also react with the concentrated H2SO4. So we cannot identify that which types of cation present in this mixture, carbonate or Cl negative, since both gives their appearance simultaneously. And if we are using only dilute H2SO4 in this solution, so in case of dilute H2SO4, there is Cl negative not react with dilute H2SO4. In that case, only carbonate react with dilute H2SO4. So we are easily finding out that this salt contains what anion, carbonate or Cl negative. So first, so always starting from dilute H2SO4, and if we are having carbonate, anion carbonate, and adding salt plus dilute H2SO4 by the adding of carbonate, if the brisk effervescence of CO2 gas comes out, the observation is brisk effervescence of CO2 gas comes out, then it shows that its salt may be contain dilute group and the anion contain maybe carbonate. That is the maybe. Now what is the meaning of brisk effervescence? Brisk effervescence means this type. When CO2 gas comes out from this solution, then with the CO2 gas, some solution also comes out from this test tube. So this is called brisk effervescence. And no doubt, if we are having a test tube and some gas like H2 or SO2 eliminated from this solution, so it gives a bubbles. And bubble, it shows that this solution eliminated gas like H2, SO2, etc. But if we are having the CO2 gas in this solution, then CO2 gas comes out from the solution, and when CO2 gas comes out from this test tube, then some solution also comes out from this solution. So why CO2 is called brisk effervescence. Now in that case, we are saying that our salt contain carbonate maybe. Now it's a maybe. Next, how we can confirm that this salt definitely or 101% contain carbonate? So we are taking a confirmation test for that. For the confirmation that we are simply using the CO2 gas that is comes out from the test tube with brisk effervescence. This CO2 gas passed in lime water. So we are taking in a test tube that gives CO2. This CO2 gas passed through second test tube. This contains lime water. And the observation is that when CO2 gas passes through this lime water, then this solution turns out milky color appear. This milky color is due to the formation of calcium carbonate. It's insoluble, that becomes insolid. So when we are, and the formula is lime water, it's calcium hydroxide. So when CO2 gas passes through in this solution, then calcium hydroxide reacts with this lime water, and finally we are having the milky color due to the formation of calcium carbonate. So and if we are passing excess of CO2 gas in this solution, then after some time this calcium carbonate disappears and gives a colorless solution due to the formation of calcium bicarbonate. Since calcium bicarbonate is soluble, aqueous or soluble, so these two tests confirm that our salt confirm carbonate. Is carbonate confirmed? But here is the problem is that this similar types of tests given by the SO2 gas. If we are having SO2 gas, here is in place of CO2 gas, then when SO2 gas pass through lime water, then SO2 gas also form a milky color due to the formation of calcium sulfite, that is CaSO3. And if we are passing excess of SO2 gas then it also forms calcium bisulfite, which is also soluble in water. So we can see that carbonate, that is CO3 2 minus, and sulfite, that gives CO2 gas, both are giving this gas. Both are giving this test. So we cannot say that this salt contain carbonate or sulfite. So we are using another confirmation test for confirming the carbonate. Now if we are using redox test. In the redox test, the CO2 gas, which is liberated in step first, passed through KMnO4 solution. CO2 gas passed through KMnO4 solution, and the color of KMnO4 solution is violet. So in that case, color of KMnO4, that is deep violet, is not decolorized. Why? Since in that case, when we are passing CO2 gas, a test tube which containing KMnO4, that is a deep violet color, then what happen? In the CO2, OS of the carbon is +4 and the KMnO4 OS of the manganese is +7. So in that case, both are in their highest OS. The highest OS of the carbon becomes +4 and highest OS of manganese becomes +7. So in that case, reaction is not possible since both are having their highest OS. So redox reaction is not possible. That's why color is not decolorized. So if the color is not decolorized, then we can say that the salt contains carbonate. Now our next test we can confirm if CO2 gas pass through K2Cr2O7 solution, potassium dichromate, O7 solution, potassium dichromate, and the color of dichromate is orange color. So in that case, orange color of K2Cr2O7 is not decolorized. Since in that case, the CO2 in that carbon in the +4 OS does not react with the potassium dichromate K2Cr2O7, since in it chromium is the +6 OS, that is the highest OS of chromium, and the carbon is +4, that is also highest OS of the carbon. So CO2 does not react with potassium dichromate, hence color is not decolorized. So we can say that carbonate is confirmed. So by the using of these two redox tests, we are finding out that solution what anion, that is sulfite or carbonate. Now if we are having salt and adding dilute H2SO4 to the salt, salt contains sulfite SO3 2 minus. Then by the adding of dilute H2SO4, it gives SO2 gas, and it has a pungent smell or suffocating smell. Then we can say that sulfite may be. Now for that we are using the confirmation test. First become when SO2 gas pass through lime water, like carbonate, then it turns milky due to the formation of calcium sulfite, and if excess of CO2 gas passed, it becomes a colorless due to the formation of calcium bisulfite. So we can see that sulfite confirmed, but the problem is that similar types of test is given by the CO2, which we have already discussed. So we are using the redox test for this. Now we are using a redox test. There are two redox tests. The first become when SO2 gas passed through K-manifold solution that becomes violet in color. Then in case of SO2, it becomes decolorized. And the color is not decolorized in case of CO2 gas. In case of SO2 gas, this SO2 gas react with K-manifold. When that Mn is plus 7 and sulfur is plus 4. So this sulfur reduces this K-manifold in plus 2 and this manganese oxidizes this sulfur in plus 6. So after the reaction, the product becomes Mn plus 2 and SO4 2 minus. Since Mn plus 2 is colorless, so color becomes disappear. So if we are passing the SO2 gas in K-manifold solution, then color becomes decolorized due to the formation of Mn plus 2, so it confirms the sulfite. Now next, redox test. If SO2 gas passed through potassium dichromate solution that is orange in color, then here is green color is obtained. Due to the chromic sulfate. CO2 gas does not react with potassium dichromate. In case of carbonate, the CO2 gas does not react with potassium dichromate, but in case of SO2 gas, it does react with potassium dichromate and gives a green color solution due to the formation of this green chromic sulfate. So we can say in that case, sulfite is confirmed.